Welcome back. Today we will be solving one LeetCode question. Climbing stair. You are climbing a staircase. It takes n steps to reach the top. Each time you can climb either one step or two steps at a time. And how many distinct ways can you climb to the top? Example, let's say we have the top equal to or n equal to, and how many different ways that we can climb from or go from 0 until 2? The answer is 2 different ways. The first way is we take one step at a time and then another step so that we can reach the top, which is 2. The second way is we take 2 steps and then we reach the top. How do we solve this problem? Let's say we have n equal 4 or the top here is 4, and the goal here is to go from 0 or to climb from 0 until we reach the top, which is 4. And how many different ways that we can do that? Here we can do one step, another one step, and another one step. Here we can reach the top, which is 4. This is one way. And another way is we can do one step, and then one step, and then 2 steps. So this will reach 4. Also another way is one step, 2 steps, and 1 step. And the other way is 2 steps, 1 step, and 1 step. And the last one is 2 steps and then 2 steps. These are the different ways that we can go from 0 or climb from 0 and reach the top, which is 4. And there are 5 different ways. From the prompt, we also know that we can climb either 1 step or 2 steps at a time. Let's say if we have n equal 2, how many different ways that we can reach the top? So the first way is we can do 1 step and another step, or we can just do 2 steps. So these are 2 different ways that we can reach n, which is 2. What about when n equal 1? How many ways that we can reach 1? So the first way is take 1 step, and that's it. There's no other way that we can reach 1 beside this way. So when n equal 1, we have 1 way, and when n equal 2, we have 2 way. And based on this deduction, we have the base case that when n equal 2, we have 2 way, and when n equal 1, we have 1 way. So here our base case is when n equal 2, we have 2 way. When n equal 1, we have 1 way. Now let me clean up the example a little bit. Alright, so instead of thinking how we can go from 0 to the top, which we call the bottom-up approach, we can also use the top-down approach. We start from the top or start from the result and then work our way back to the original state, or work our way back from n until 0. Let me show you what I mean. Here we have n equal 4, which is the top. And how do we get to the top here? So we know that to get to the top, we can come from either taking 1 step or 2 steps at a time. So here n is 4. And to get to the 4, to get to the n here, it is coming from n minus 2 or n minus 1. So to get to 4, we come from this step or come from this step. How do we get to this area? To get to this area, to get to this spot, it can come from either 1 step or 2 steps. So it can come from n minus 2 or n minus 1. And what about n minus 1? N minus 1, we know that it also coming from n minus 2 and n minus 1. Let's plug in the real number. So here we have 4, and to get to 4, we come from n minus 2. So 4 minus 2, which is 2. And 4 here, we come from n minus 1, and 4 minus 1, which is 3. And here 3 minus 2 equal 1, and 3 minus 1 equal 2. And here we also have the base case. When n equal 2, we know that we have 2 way. So when n equal 2, we stop, because this is already our base case, and we have 2 way here, right? And when n equal 1 here, we have 1 way. And when n equal 2, we have 2 way. And now we can just add up all different ways that we can find here. So here we have 2 way plus 1 plus 2. So the answer to get n equal 4 is 5. We have 5 different ways to get to 4 here. Let's code out the solution. First, we know that our base case is n. If n equal 1, we return 1 immediately. And if n equal 2, we return 2. And then what we want to do is we want to call the function again, climb stair. And then we work our way back from the top to the bottom. And here we can have n minus 1 or climb stair n minus 2. Remember, to get here, we come from either n minus 2 or n minus 1. That's why we pass in n minus 1 and n minus 2. And we know that at the end, we have to add up all the way that we can find in order to get the total different way that we can climb to the top. So here we're going to add climb stair n minus 1 plus another climb stair n minus 2. And at the end, we can just return back the result. This kind of implementation work, but the runtime is going to be 2 to the n. Because here we always make 2 recursive call. You can see here, 4, we make 2 recursive call to the bottom. And from here, we make another 2 recursive call to the bottom. And also here, we make another 2 recursive call to the bottom. So the runtime is going to be 2 to the ends, which is very slow. But the good news is we can make it run faster. Notice that here we have 2 and here we have 2 as well. So what if we implement some kind of caching or some kind of memorization to help our function? Let's say here we already calculate when it is 2. And if you see 2 here, you don't have to calculate it again. Just use the previous result. Let me show you what I mean. Here we can just pass cache or memorization. And then we initialize it with an empty object. Here we check if n here is in our memo, our cache. If it is in our cache, we can just return immediately. We can just return the memo. Then we can just save here. I'm gonna save here in 1-step variable, and here 2-step. I will put the result here in the cache. So memo n equal 1-step plus 2-step. And at the end, we can just return back the cache. This will significantly improve our implementation because we don't have to recalculate the same n over again and again. Here we also have to pass down our cache to the recursive call so that it can look up the memorization. And now let's check the result. What is the time complexity for our implementation? The time is gonna be O of n because we have to work our way back from n until the base case until the bottom. And for space, it's gonna be O of n as well because here we're storing the previous result in order to avoid having to calculate the same n over again and again. Hope you guys enjoyed it. See you next time.